Okay, so this next problem is an AP exam problem again. This is a non-calculator problem, okay, unlike the previous one. So they've given you a graph of f, and they defined a g function as the area under the curve from starting at -3 to some point x, which is represented by the x variable there. So again, notice that the variables are different there. So this graph that's given essentially is a g prime graph. Okay, that's a G prime graph. And the area underneath that graph, so that's F and G prime are the same thing. So the area underneath that G prime graph defines some point on G as the area from -3 to X. Okay, now it's important to understand there's -3. Going to the right, when I integrate to the right, I'm going to end up, that's our regular positive. So above is positive, below, area below is negative. When I go to the left, however, it's going to be opposite. Okay, so the area above is going to be the opposite. So that's going to be negative area or negative displacement because I'm going backwards in time. Okay, so it looks like I went backwards here. Okay, if I was thinking velocity, I'm going backwards. But if I go backwards in time, I actually gain positive displacement. Okay, so that's one thing, first of all, we have to establish. This function is the derivative function of g. The g function is defined from this point arbitrarily from -3 to the right is going to be positive, to the left is going to be negative. So it says find g of 3. Well, I need to find g of 3. I'm going to find the area, okay, from negative. It's going to zoom in a little bit, but I want to find the area, okay, from -3 to 0. Okay, so that's going to be I want to find g of 3. So -3 to, actually, sorry, I want to go from -3 to +3. Okay, and that +3 here is the end point of that function. So I calculate my area starting there, ending there. Okay, so that's going to be of f of t dt. Okay, so I take a look at my graph here. The area from -3, the positive area, I'm going to end at +3 there. So from -3 going to the right, this area in here is going to be positive displacement. It's going to be 1, 2, 3, 4, 5 wide. It looks like 4 high, so it looks like an area of 10. Okay, and then I'm going to be going backwards, so this is a negative displacement. So from, looks like 2 to 3, I'm going down. So it's got a width of 1, height of 2, so an area of 1. Okay, so I'm going backwards that amount. So g of 3 then, the g coordinate at x equals 3 is then equal to 9. So then I have an ordered pair of 3, 9. Okay. For part B, it says, on what open intervals is the graph both increasing and concave down? Okay, so that means that what's happening on g prime? G prime, if it's increasing, g prime is positive. Concave down means that the slope of the slope, so g prime must be decreasing, okay, which means that g double prime is negative. Okay, so this is the slope on the g prime graph should be negative, which means this, the second derivative of g prime is going to be negative. Okay, that means concave down. So I want to know where the g is both the graph here, the f or the g prime graph is positive and sloping down. Well, the intervals that we're looking at are here. Okay, so I'm just going to do that. So where it's positive, it's here and it's sloping down. Where it's positive, and sloping down is here. So these two sections here are going to represent my positive slope, okay, because the slope is positive here. Okay, so G prime is positive, and the second derivative is negative, or the slope of this graph is negative. So G prime is positive here, which means that G is sloping down. Sloping up, and G prime, the slope of G prime, which is G double prime, or the concavity, is going down, so it's negative. So those are the sections that we're looking for. Okay, so my intervals then work out to be -5 to -3, and that's going to be up here, sorry. Answer to be -5 to -3 interval. It's also going to be from 0 to 2 interval. Okay, those are the intervals that we're talking about that are sloping, that are going to be have positive slope or positive y-coordinates on the derivative graph, and negative slope on the derivative graph, which means the second derivative is negative. Okay, those are the two sections. Okay, so let's see here. Part C says the function h is defined by the quotient function there, g of x over 5x, and it says find h prime of 3. So let's differentiate h. So we're going to end up with g prime of x times 5x minus g of x times 5 all over 5x all squared. Okay, so I think we can cancel out the 5's here, can't we? Yeah, we can. Well, we'll just leave it like that for now. And it says find h prime when x is 3. So we're looking for the g prime value when x is 3. Well, that's the same as f of 3, because this is a g prime graph. When x is 3, y is -2. Okay, so g prime of x is -2. X is 3, so I'm just going to plug the 3 directly into my x. G of 3 times 5. So I don't have a g graph. Okay, remember that's a g prime graph. But look at here. I did solve for g of 3 here. G of 3 is equal to 9. So I'm going to replace that afterwards. So I'm just going to maybe just highlight that for now so I don't forget. That's my g of 3. Okay. And then on the denominator, plug in my x. So I get 5 times 3 all squared. Okay, so the only thing really in question here really is my g of 3. So just working this out, 2 times, so that's -30, minus g of 3 is 9 from above. Okay, and then that's going to be 15 squared, or 225. Working that all out, it's -75 over 225, which is equal to -1 over 3. Okay, so the derivative of h at 3 is -1 over 3. So the last part of this question is part D. It says P is defined by f and with an embedded function x squared minus x. So I want to find the slope of the tangent line of P where x is equal to 1. So basically I want to find P prime of 1, right? Which means I need to find the derivative. Okay, so I'm going to differentiate this. I need f prime at x squared minus x times, since it's an embedded function, I need to differentiate the inside function using chain rule. So there it is. So I need to be able to evaluate the slope of f, which is a slope of this graph, at x equals whatever, in this case, whatever that expression is going to work out to be. So P prime at x equals -1, I'm just going to sub in right now. So -1 squared minus positive 1 minus negative 1 is going to be 2 times 2 times negative 1 minus 1. Well, that part's easy. I just now have to establish what is the slope on the f graph at x equals 2. Well, x equals 2, that is going through the axes. So I'm looking, what is the slope of that line, that green line segment there? Well, I can see very clearly that's the slope of that whole line. The slope of that line looks to be a 1, 2, 3, 4 down, 2 across. Slope is negative 2. So I'm just going to plug that in then. That represents the slope at 2, okay, through that section. So I end up with a slope of negative 2 times, that becomes negative 3. So the p prime value at negative 1 equals 6.